Now,
Ah,
now we will start.
yeah, you can. Actually,
Yes.
I have started my PC also so that I can view you. I have
Okay.
two screens now.
Okay, sir.
Okay. तो पूजा डॉक्टर पूजा यादव के नाम से किया है मैंने. हाँ.
Am I start?
Yeah. Still, it is not visible, I guess.
A very happy morning to all the faculty members and my dear students. On this pleasant morning, I have Shakhan take this privilege to warmly welcome to all in this webinar on computers in biomedical engineering and its future prospects. I, on behalf of Prerna College of Commerce, would like to thank every one of you for taking time out of your busy schedule and joining us for this event. It's my privilege to introduce our honorable speaker, Dr. Nilesh Deepak Meshram. He is head of electronic department in Sri Mathura Das Mohta College of Science. He has given his 15-year service in Sri Mathura Das Mohta College of Science. Sir has awarded PhD in electronics. Dr. Nilesh Mishram has been published more than 42 research papers in international journal as well as conferences. He has attended more than 45 conferences of national and international repute, where his work has been strongly appreciated. Now I request him to begin the session and enlighten us. Sir, over to Dr. Nilesh Meshram, sir.
Thank you, ma'am. Thank you very much for giving such a wonderful introduction. And I guess I'm audible.
Yes, sir.
Thank you. So keep me updated if I'm not audible at some time.
Yes, sir, sure.
So maximum are students over here who are from computer science, I guess, right?
Yes, yes.
So friends, it's my great privilege and honor that I'm sharing virtual dais with my gurus, uh, Dr. S.P. Joshi sir. He taught me in 12th in English, and it's really a great honor for me that I'm sharing a dais with him today. Friends, we are starting today with a topic which is very much relevant to your computers. So that is how I choose my topic as computers in biomedical engineering and its future prospects. So we have a wide range of opportunities lying in this field, that is biomedical engineering. So just we'll go through that. Let us start the presentation. The first one is that a famous quote by Thomas Edison, who was a businessman as well as inventor, and he said that the doctor of the future will give no medicine, but instead will interest his patients in care of human frame, in diet, and in the cause and prevention of the diseases. What type of vision these peoples were having? He told in those days where there was not much technology, but still he was able to say this that doctors will not give medicines, but not only give medicines, but they will take care of the humans, and the same is being continued by these computers itself. So coming back to our topic, friends, uh, today the topics that is to be covered in this my deliberation will be some background of the information, introduction, application of DSP in biomedical engineering, some of the sensors and transducers which I guess will be important, and some of the devices which are vibrantly used in this field. And then I will sum up with some microcontrollers, IoTs in healthcare, then the future prospectus and your job opportunities, and lastly I will conclude. So these are the topics that is expected to be covered. So let us start. So what is the background of this biomedical engineering? So it started in the late 1960s, where digital signal processing began. So digital signal processing was the major breakthrough in this biomedical field. And why it is very important? Because this digital signal processing, or these digital signals, can be reproduced exactly as it is. So that can be done. And the second foremost advantage of using DSP is they can be manipulated as well as they can be recorded. So the data can be stored and the data can be analyzed and can be used in the further processing. So this was the need of digital signal processing, and this actually is the major branch of technology which is concerned basically with the biomedical engineering or the healthcare field, right? So these uh, DSPs are now being widely used for the better upliftment of healthcare. So, starting with this, what is actually a biomedical engineering? What is actually, when we should understand why we require this biomedical engineering? So, a biomedical engineering is actually the application of knowledge and technologies to solve problems related to living biological systems, right? So, the knowledge that we have can be applied actually to the betterment of healthcare, and that can be used, which involves measurement of biological signals like ECG, EMG, CT scan, dialysis, and lot more to come. Right. So those are some of the systems where the electrical signals are being generated by the human body and they are being stored and being reproduced. Right. The second most important is the diagnosis part of it, whereas treatment and prevention of diseases in humans. So these are some of the things which are very much important in this COVID-19 pandemic also. And you might be listening to this, that the researchers are being widely using their talents and technology uh, to develop this say antibodies for this treatment of COVID-19 pandemic. So these are the important field where we have. Then the DSP system. What actually the DSP system consists of? So as you are able to see over here, we are having a block level diagram of this digital signal processing system. The first one is the analog input that we are having. So whatever comes physically, or the physical parameter that we are getting it from the environment or the from human body, that is called as the analog input. Now this input is first filtered and then it is limited to a certain signals, that is called as band limited signal, and this is given to a ADC. This ADC converts this analog signal into digital form, right? So this is called as analog to digital converter. And now the digital signal can be processed by this DSP, that is digital signal processor. That might be a microcontroller, that might be a computer. And this can be recorded, as well as this can be given to DAC. DAC means again back to analog signal, that is digital to analog converter. And this analog signal can be reconstructed and given to a printer, or say for the reports that we get from the doctors or from the pathology lab. So these are the systems that we are having. So now this DSP is playing a major role to analyze and visualize data and perform their design and so on. So these are very important factors of biomedical engineering research. And medical instruments will be less efficient for precise diagnosis. If we talk about, say, the analog instruments that are having that were we were using in the early ages, so those instruments were not that much efficient to give the results. You might be remembering that the doctors were using reproduce the sound of heart, and they used to put it on your heart and they used to check your heartbeats whether they are coming proper or not, and accordingly they give the medicines or not. But now we are having a digital or a electronic stethoscope which gives you the whole detail of it. So a display is over there. If you just put it that stethoscope on your chest, it will give you the readings. So see the tremendous change that technology has done towards the medical field, and there is a lot more that can be done in this field. So this is the basic block diagram of digital signal processing. And uh, mm, why we need actually the DSP engineering in medical field. Now, if you are able to see my screen, you will be able to know that how digital signal processing is effective. Now, whenever we are having an accident over here, they are being the treatment has been started in the early phases itself while carrying it. So we have the emergency ambulances which are having all the equipped devices over there, and the treatment starts in the ambulance itself. So all those instruments are being required, and those instruments are actually made of this digital signal processing systems. So that can be done, and these are the some of the basic things where we are. The DSP engineering is required. So now the major roles of computers in medical field are why we require to maintain the record systems, maintaining the record systems of patients, then billing and financial system. There also the computers are being employed. Then we have having analysis, so we can check the results, we can create the data, and we can say the data. We can keep the history of those data, and accordingly we can give the medicines and all. Then material management, then radiology, clinical management, tracking patients. All these things are being maintained and done by computers nowadays. So all the data is in digital form. So these all the things are being widely used by these computers. So these are the major roles of computers in medical field. Then the purpose and uses of computers in medical field. These are, I've already told you, diagnosis, CT scan, X-ray generator, ultrasound, telemedicine, and nowadays we are having virtual surgery also. So we can do a surgery virtually. The doctors are doing by their hand on a screen, and the robots are performing the surgeries at some other place. So those virtual surgeries can also be done by using this computers or these DSPs in medical field, right? So these are some of the advantages of using this. So let us start with some of the basic instrumentation system signals. So now, as I can, is the screen is visible to you all. Human physiology has many of the things that can be recorded. So the energy sources, electric, light, infrared, mechanical, ultrasounds, everything is there, and that can be used for the measurement of parameters like temperature, heartbeat, ECG, EMG, EEG, and CT scan, X-rays, all those things, and they can be calibrated, they can be given to the sensors and transducers, then the amplifiers come into play, then they are being given to signal processing. This is the control system which we are talking about. So this is actually the DSP system which is controlling all those things. And lastly, it can give it to alarm, or it can nowadays it can be directly it directly gives a phone call to the doctor, specialist doctor, display, data storage, data transmission, and data recording. So these are the basic instrumentation, biomedical instrumentation system that works in unison with the doctors as well as the healthcare workers. So this is the basic instrumentation system. Then the applications of DSP in biomedical engineering. So those are, now as you are able to see, this is the ECG block diagram, and these are the electrodes that are being employed on the human body. 1, 2, 3, 4, 5, and the signals are being taken, and accordingly they are being calibrated, and they are given to a multi-channel AD converter and a microcontroller, actually RF interface, and then they can be transmitted through mobile, or say through internet or wireless communication, and the at the server, and this data can be used for further processing. And more than that, the say diagnosis can be done virtually from a distant place also. So this is the basic applications of DSP in biomedical engineering. Then these are some of the sensors that I need to tell you, because we should understand what actually are sensors. Now these are the basic small elements which are going to give you these parameters back in electrical signal form. So if you are able to see here, there are many small transducers which are available in markets. Even you can purchase them, and you can make your own electronic biomedical gadget by using this. So you are having here heartbeat sensor, IR sensors, and touch sensors. You are having ultrasonic sensors, or their thermistors, which are being used widely used in temperature. And then we have smoke sensors, gas sensors, alcohol sensor. These are proximity sensors. All types of sensors are present over there, and those sensors are just giving you the uh, proportionate electrical signal of those parameters, right? And that can be manipulated and being processed. So these are some of the sensors that we use. Then let us start a simple basic heart rate sensor for Arduino by using Arduino pulse sensor. So Arduino actually is a small microcontroller based device. I need to show you that, and I will be talking on that also, because that those devices are now widely being used. So this is that pulse sensor, a small, this is very small, say in a size of say a coin, and it's having say, it shows you a vibrant sort of thing, and that can be connected to this type of a circuit, and this kit is actually called as a Arduino kit. This is a very basic circuit of microcontroller, and easily available at the marketplace, and very cheap. Say I have brought it at rupees 250 rupees per like some like someone something like that on that, and this is around 50 or 60 rupees. So if you go through that, the devices are so easy and so cheap over there. And then yeah, so this is over there. Then we have some biosensor. Now look at the sensor. The tip of that, we are having a biosensors, and these biosensors have 5 components: biological sensing element, then transducer, signal conditioner, data processor, and the signal generators. Just imagine if all these components are inbuilt in this small chip which I'm showing you over here, and these can be programmed. So these chips are nowadays playing a very vital role in healthcare industries, and they are very small. So we can have, say, heart replacements also, like pacemakers, and also those microcontroller chips, small chips can work. So this is the strength of that. Now we are working in nano technology, and also all these components are being inbuilt inside this small chip. So those are biosensors. Then the applications of DSP in biomedical instrumentation, I'm talking just on this, so that you should be able to understand what type of use this DSP is having in biomedical instrumentation. So I'll be talking on this also. So the first one is coming like hearing aid. So a small device which is used for those who are barely audible. So those signals are being amplified and given. So I'm talking on that. I will be talking on ECG. I will be talking on CT scan, dialysis, and some more instrument. I just need to brush it, show you all those things, so that you should come to know that what type of instruments are being used in nowadays. So hearing it. Yes, initially I will start with some of the or analog hearing aid. So what hearing aid is? A hearing aid is an electronic sound amplifier. It's just like a loudspeaker or an amplifier kit, but it is in a small size. Like, so we have a mic, we have a amplifier, and then we have a big speaker. So if I need to talk, so I have to say it in a mic, and then I have to hear it on a speaker. So the same is being used, the same concept is being used in a smaller manner in a hearing aid. So that is called as the analog hearing aid. And we have one more, that is a digital hearing aid. So I am going to show you both of them. So the first one is the analog hearing aid. So what it looks like, see. So this was a hearing aid which was used earlier. It was having a microphone, a small microphone over here, and then we were having an amplifier. This is a small battery which is connected over here, and this is actually a speaker. And now this is given to a tunnel over there, and it gets inside it. So the sound waves travels through this, and the person who is not able to hear can be used, can maybe um, able to hear those things properly. So this is the analog hearing. And now let's start with the digital hearing. Now look at the system. If you see this, it's a very wonderful device. So this is a very small chip which is inbuilt inside it, and they are now coming in a very good sorry packages, and they are very formal packages over there. So we are having all side processor inside this, and it is doing all the job for that, and we don't require anything else. Then we'll require the battery, mic, and the speaker. That's all. And all is the programming is done inside it. So there are various types of these instruments which are called as digital hearing aids. So they are also available in the market. So this is the advantages of analog hearing aid, and say the difference. We compare. I've tried to compare both analog and digital hearing aids. So analog hearing aids are generally cost less than the digital hearing aid, are sometimes more powerful than digital hearing aids, and long time hearing aid users sometimes prefer analog. So long time के लिए ये बहुत अच्छा है. Other than that, these can be programmed with noise reduction algorithms to help reduce background noises, highly programmable for various listening environments, most flexible and adjustable for specific user of needs. So see the difference between a digital hearing aid and an analog hearing aid. So at that point, you will be able to know that digital hearing aid are more convenient and more say uh, technologically advanced with respect to analog hearing aid, though they are like a use and throw type of devices. Once it is being say stop working, then you won't be able to use. That is the main drawback of that. But still, the next one is the electrocardiograph, ECG. You have heard many a times that ECG karna, ECG karna, ECG karne ke liye bol raha hai doctor. So what actually that electrocardiograph is? It is actually the impulses of heart taken by an instrument, and whether it is working or not. So it contains this type of a block diagram. It contains a microcontroller, again a digital converter or is there. Then we are having electrodes which are connected to the human body. Then this is the ECG signal measurements. Desired input is ECG voltage, interfering input is 60 to 50 hertz. Then modifying input is orientation of the patient cables there or there. And this is how some of the things does. So as the heart pumps diastole and that is systole. So it pumps and it gives you an impulse of this. So it has a rotational as well as linear motion, and accordingly you will have these impulses. And if there are any anomalies in the uh, heart, then they can be checked by using this ECG. So that is done over there. And this is the ECG signal. I just wanted to tell you about that. Then we have electroencephalograph, EEG, that is actually recording the waves of human brain, right? That is called as EEG, electroencephalograph. So this instrument records signals from human brain. Signal parameters and patterns indicate the health of the brain. EEG is the key area of biomedical data analysis. DSP play an important role in to analyze this EEG signals. Now, how it's going to analyze its characteristics and origin of brain waves. So we are having this 5 types of frequencies that are coming out of our brain waves, and those brain waves can be recorded and can be say analyzed, can be used to check whether the brain is working properly or not. Like if we are having alpha wave, then the frequency range of alpha wave is 8 to 12 hertz. Now, if the person is having this, then it is in the resting condition, sitting in a relaxed position with eyes closed. And source of generation is, this is the some medical terminology. We won't go in depth over there. Then we have a beta wave, which starts from 12 and ends up to 30, means mental thought and activities. Eyes are open. Gamma waves greater than 30, cognitive function, sensory stimuli, motoric activity, and heavy activities कर रहे हैं. Then we have a delta that starts from 2 to 4, that is a deep sleep. And then lastly we have a theta wave which is from 4 to 8 hertz, that is a sleep. So these are some of the waves which are being uh, taken from brain and can be used for analysis of a patient. So this is called as EEG, electroencephalogram. Then we work on CT scan. Yes, what actually is a CT scan? Again, a CT scan is a computerized tomography which combines a series of X-ray images taken from different angles around your body and uses computer processing to create cross-sectional images, that is slices of bones, blood vessels, and soft tissues inside your body. CT scan images provide more detailed information than plain X-rays. तो एक्सरे सिर्फ आपको एक ढांचा स्केलेटन देता था आपके इसका. अब ये पूरा का पूरा आपको ओवरव्यू देता है आपके ब्लड वेसल्स के बारे में, आपके बोन्स के बारे में, और आपके से सॉफ्ट टिश्यूज के बारे में क्या सिचुएशंस है, एंड दोज आर बीइंग एनालाइज्ड ऑन कंप्यूटर्स इटसेल्फ. Next one is a dialysis. Dialysis is again a major equipment that is used for the purification of blood. That those are very costly nowadays. So those are these are there which these heart gives the impure blood, and this dialysis instrument will give us again that the pure blood, oxygen rich blood to the heart. So artificial ventilators is one more device there. It works. So it keeps the purified air or oxygenated air into the lungs. So nowadays you might have listened about when COVID-19 was on peak. So all were worrying about the ventilators. So there were less ventilators in the hospitals also. Even some artificial and small ventilators are now present in the market, which can be purchased by a person for their personal use. So those ventilators are there. So these are artificial ventilators. See, these are some of the major applications of devices which are being widely used by digital signal processing. Some of them are DSP, blood pressure measurements. So what is a blood pressure? This is one more term which is coming widely across our minds. So blood pressure is one of the physiological variables. Now the instrument that uses that measures that is called as manometer, which determines the blood pressure with other means such as heart signals. And BP indicates the force with which blood is driven through the heart. So with what force the blood is taken out, pumped inside and out. And it is divided into two sections, systole and diastole, right? Systole and diastole. So this is called as blood pressure. This can be also monitored. Then we have some of the wearable monitoring devices coming widely being used nowadays, and those devices which are being widely used are like watches. So we are having now healthcare watches which show you temperature, heart rate, even the motion, how much steps you have walked. And one of the watch I also having is which shows you all the kinds of walking and other things. So we are started to use these types of variable monitoring devices. So the devices are now being getting so smaller that they can be uh, say uh, wrapped on your wrist, and they can monitor your health. So these are some of the variable monitoring devices, and this shows you how technology is reducing its sizes, right? So once I heard that computers, when I started, the first computer was made on a 1200 square feet say area. Now the computers are reducing, and they can be they are reduced to have in a mobile also. So a mobile is just similar to a small computer which works on that. So we are working on this. So these are some small of the small devices which are monitoring our healthcare, our heartbeat, temperature, and etc. And they can also be connected to mobile phones directly also. So these are there some wearable monitoring devices. I just need to tell you how the technologies is being advanced. Now basic things, various microcontrollers that are being employed in healthcare industries. I need to talk on this because this is the crux where we have a lot more opportunities and where we can do wonders. So these are this Arduino I was telling you, these are some of the microcontrollers at MEL, AVR, ATX, at Mega, 8051. These microcontrollers are being taught to computer science students. Actually, they need to learn about the programming of 8051. And then I've talked about Arduino, ARM. There are many more microcontrollers. Sorry, sorry. So that can be used and that can be programmed. Uh, So I need to talk on this microcontrollers because these are taking this biomedical field in a different direction. So while studying computers, you need to learn about the softwares. You need to learn about the programming. So you should understand those programmings. Unless and until you do that, you won't be able to program these sorts of chips. And if you do this, then you can do wonders. You can record systems. You can make instruments. You can go for research and many more things. Like so, these are some of the smaller devices which can be programmed accordingly, which can take the data, which can take the analog data from a human body, and they can be manipulated, they can be processed, and they can be printed, or they can be given to other recording systems also. So those are some of the microcontrollers. And uh, I need to talk on this Arduino peripherals. So the Arduino kit, it comes in all setup, so we don't have to do anything over there. This is inbuilt everything, and this costs around 250. So we are having some input output signals. These are power supply. This is a crystal oscillator inbuilt. This is a voltage regulator IC. This is a power button over there. This is a USB. You can connect your say computer through this, and you can program this Arduino kit by using this. This is the power LED and all. So these are peripherals, and you can take the output from this output signals, and then these are some of the analog pins which are connected to this kit itself. So the kit itself is over there, and I have shown you that there was a small hard sensor, right? So that sensor can be connected to this Arduino kit and can be used. Now, how by where we are going to learn this? So there are many simulations available on net. So this is one of that simulation, Tinkercad, which gives you all the softwares and small programs which are there, and you can use that free of cost. So go to Tinkercad and use those programs, and you can run your small sensors on that, and you can use this Arduino kit. So that's very simple to use. Everything is available on net. You just have to uh, go through that and just learn. There are many softwares free of cost, many programs written already over there, and that can be used. You just have to buy those devices, right? So this is the gallery of Arduino which I need to show you, which is available on Tinkercad free of cost. So this is the some design circuits. This is say the ventilator.com, and sorry. So these are LEDs based, these are ultrasonic based devices. Then this is digital to analog converter. This is LCD interfacing program. So these are switches program. These all are written over there in Tinkercad, and we can use those programs, and we can program the Arduino kit, and we can develop our own personal circuit by using this software. So why I need to talk on this, because these are available free of cost in the net, and just we don't know that these are there. So just to introduce that, I need and there is one more. This is called as Raspberry Pi 3. So this is actually nothing but a CPU unit that we are having. So this is a small CPU, believe me, and it has everything. It has got USB, 4 USB channel. Then you have that jack channel, then it is having Bluetooth, it is having Wi-Fi and everything. So everything is inbuilt in a very small chip, small kit, and this is equivalent to a Pentium PC processor CPU, as you are able to see on my screen. So this small thing can do wonders. Now the professionals of DSP or digital signal processing, basically computers or hardware or software engineers, they are working on these Raspberry Pi, and these Raspberry Pi 3 are widely being used. The cost of it is very less, that is around say 3,000 or 4,000 rupees. You can connect to your screens, you can connect to keyboard, everything you can connect, and you can work like a PC. So this is Raspberry Pi, which can be programmed. It is having Bluetooth also, it is having Wi-Fi also. It can be connected widely through internet, and IoTs, that is Internet of Things in healthcare, can be done by using this Raspberry Pi. Let me talk more on this. So Raspberry Pi, what is Raspberry Pi actually? So Raspberry Pi, which is a credit card size single board CPU and is developed by UK by Raspberry Pi Foundation in 2009, and I'm talking it in 2020 for you people. See how we are developing. So the concept initiated by Eben Upton, who works at Broadcom. Now, to promote the study of basic computer science studies in schools and colleges to develop interest among the kids and adults. So these Raspberry Pi kits were developed for to develop the interest of students who are learning computer science. So these are the basic CPU units that can be widely used in any of the application, not only in biomedical engineering, but any of the fields. So Raspberry Pi, and then Raspberry Pi 3 peripherals, which they are having. I have talked on this. So it can be connected to internet through link or through wires. Then we are having USB 2 ports, 4 ports actually, 1, 2. And then it's having a CSI camera port also, then audio video port, HDMI cable, then we have micro USB power, then DSI display port, micro SD backside, so you can put SD card over here. Also you are having Bluetooth. Then this is a CPU unit that we are having. Memory, it is also present. So everything is over there on a Raspberry Pi 3 peripheral, so that can be used. And actually this is being widely used in foreign countries by students themselves. So Raspberry Pi, and it works on Wi-Fi also, I have already told you. So in IoTs we use. So general platforms for Raspberry Pi 3. So these platforms are available free of cost for everybody, and they can be used. So these are some of the platforms, programming platforms that we can work on Scratch, Python, C, Java, Ruby, Perl. These are the programming, and the project platform, GPIO, serial interfacing. This can be done, and Raspberry Pi can be programmed on C also. So it's very convenient and very easy to use and very easy to program also. So these are some of the platforms of Raspberry Pi 3. Then let me shift to IoT in healthcare. Now, what is IoT? This is a very emerging field in healthcare. IoT means Internet of Things. So what is Internet of Things? Whatever data the people's or the public is using on internet can be used for the betterment or the upliftment of healthcare as well as the other applications. Just for example, if you go through your mail account and search something on a search engine, just go through that, and believe me, the related post will start coming on your Gmail and your all the Google links. Why, how it happens? Because it is connected to Internet of Things. Whenever you search something, everything starts popping up on your screen, like Facebook and other online fields. Like so, those data which you are searching are being used by the business peoples, and that particular thing is called as IoT, Internet of Things, and they are used. So you start browsing something, and the say the results come. So those are called as the IoT, that is, and that can be widely used in healthcare. Now, how IoTs can be used in healthcare? That is what we are able to see, we will or think, right? So let us start with what is Internet of Things. A system of interrelated computing devices, mechanical and digital machines provided with unique identifiers, UIDs, and the ability to transfer data over a network without requiring human to human or human to computer interaction. So this is called as the Internet of Things. Means the data which we are using can be given to anything. If you are able to see that my talk is live on YouTube, so that is going on the cloud, that is being stored somewhere else. Now this data can be used by somebody, right? So I might be able to view my own comments and anything. So likewise, even if you go through my videos on my channel, so you will be able to hear that similar things will appear on that. Some more people have uploaded some videos, so that also comes up. So that is what is called as Internet of Things, and without the interaction of humans over there. So automatically it comes, and that is called as the IoTs, that is Internet of Things. Now let us see what IoT can do. So can you predict the chances of second heart attack by using IoTs? Just imagine. So you if you have a history that you have attacked, you have a first attack, heart attack. So how many chances are there to that you will get a second heart attack? There are many symptoms of that. So we can have those data, that what are the probabilities and what are the causes, what are the symptoms of having a second heart attack. What happens before getting a second heart attack? So that data is available on internet. We go through that, that data can be loaded, and accordingly a system can be developed, that whenever we will have those sorts of symptoms, कि say we are having पसीना आ रहा है या अनईजी फील हो रहा है, चक्कर आ रहे हैं, ऐसा कुछ तो भी अगर हो रहा है, ये कुछ तो सिम्टम्स हम लोगों ने वहां फीड करके रखे, ऐसे अगर कुछ दिख रहा है तो ऑटोमेटिकली जो हमारे डॉक्टर्स है, स्पेशलाइज है, उनको ऑटोमेटिकली कॉल चला जाए कि हमको शायद सेकंड हार्ट अटैक आया. And this can be done by using IoTs. Why? Because we are having a data with us. हमारे पास वो पुराना डेटा अवेलेबल है, वो डेटा हम लोग यूज कर सकते हैं. जिनको सेकंड हार्ट अटैक आया है उस वक्त उनको क्या सिचुएशन, उनको क्या सिम्टम्स थी, उनकी एज क्या थी, उनका पैरामीटर्स क्या क्या थे, उन्होंने क्या खाया था, उनके पेट में क्या था, उन्होंने टैबलेट्स कौन सी ली थी, ये सब चीजें जो है दोज आर अवेलेबल on internet and that can be used for those purpose. So yes, we can predict the chances of second heart attack and we can use. So this is the basic role of IoTs in healthcare, and which is a widely emerging field in biomedical engineering right nowadays. So this is having a wide scope over there. So yeah, what is IoT infrastructure? Now where we can use IoTs? So IoTs are widely being used in Amazon Web Services. Those are free of cost. You can use those things. Wind River, Intel, IoT Gateway, Cisco Networking Giant, Google Self-Driving Car, Nest. These are all the freely available say platforms where we can use the IoTs. So just I need to tell you that there are many things which can be done, but the thing is you have to be serious in your particular directions. You need to know what I have to do after my graduation and post graduations. So these are all available over there. Then IoT servers are there. These are also free of cost. ThinkSpeak.com, Amazon Web Services, Firebase, DataSparkFun.com, IBM Bluemix. These all are free and these are being widely used by Raspberry Pi 3. And these are the IoT servers which are available on net free of cost and that can be used. Just we need to go through that. And if you do that, you have say wonder, you can do wonders, and income is sky is the limit. Like, so that is over there. Then The next is coming is the artificial intelligence and machine learning. Nowadays, you might have heard that we are having intelligent cars without drivers. So they drive on their own, just on GPS. They are being connected, and the cars are being driven. How this is done? And that particular thing is called as artificial intelligence. Earlier, whatever computers were being told, that that much only the computers were able to do that, right? But nowadays the computers are having artificial intelligence. What it implies is it requires a particular sort of dimensions to think in a particular situation, right? And that thing is called as the artificial intelligence, right? Because at a particular situation might be a human might take some other decision, whereas a machine can take some other decisions. So yes, we can we can program the machine in that particular sort so that it will take a proper decision at that particular level. You might have also heard about autopilots. So autopilots, what it does, the planes are being driven automatically. So it doesn't require any pilot. When we sit on that, it just goes through that. So we just need to monitor that. That's all. Nothing else is to be done. So that is called as the artificial intelligence, because the plane itself has those sort of programming sectors, right? So this is over there. Artificial intelligence is again one of the emerging field, and that can be also used in biomedical healthcare industries, right? So those machine learnings actually are quickly and automatically produce models that can analyze bigger, more complex data and deliver faster, more accurate results, even on very large scale. Machine learning facilitates computers in building models from sample data in order to automate decision-making processes based on data input. So we have already programmed accordingly the data which is available on the internet, or say what we are giving to the machines, that is actually the computers, and they are being taught. So how the students or how the teenagers are being taught in their kgs, kg1, kg2, how to behave, and that accordingly that the machines can also be taught to take decisions in a particular situation, and that is called as the machine learning things, like, or artificial intelligence. Both are, and the real-time examples in hospitals are of machine learning, such detecting of cancers. These are some of the basic examples where direct relation to the machine learning. So even in healthcare also, machine learning is doing as fabulous job. Researchers and scientists have prepared models to train machines for detecting cancers just by looking at slide cell images. Just हम लोगों ने उसको देख लिया तो वो कैंसर हो सकते हैं या नहीं, उसका डेटा फीड करके रखा है, वो कंपेयर करता है और वो चेक करता है कि इसको कैंसर होने वाला है या नहीं, या कैंसर है या नहीं, and it gives you the decision. So there is no need of a doctor to tell you everything about it. So doctor might be sometimes wrong because it will have less number of samples to compare. But in case of computers, there might be uh, n number of samples which can be compared in a very small time, and the decision can be taken. So these are some of the rare small examples where say artificial intelligence or machine learning comes into play. So these are there. Then we have diagnosis of patients also based on different parameters under construction. This is what I have told you already. These are real-time examples of that. Then we are having machine learning applications like healthcare, digital marketing, spam detector. Spam detector, I would like to tell you that if you have got any phone call, and if it is related to say some banking or something like loan or something, so uh, the mobile itself shows you it is a spam call, and you can block that so that next time they won't disturb you, right? So that can be done by using this machine learning. So maximum times people used to block those numbers, and this data where these numbers are being blocked is being recorded in the internet, and the machine next time tells you that yes, this is a spam call, so you should take care of that. Then we have a search engine, Google translators. We are working on that. Even you speak, it can be converted into different languages, and it can be written on the word. Everything is over there. Then we have a traffic alert. Then we have a social media which is working on this, machine learning applications and all. So these are some of the major applications of machine learning and artificial intelligence. I guess these are some of the important things that I have expected to tell you, and maximum things are the emerging fields, and peoples are working on this. Let me start with this now, which are very much concerned about you. Now, the main concern of a graduate student or a person who is doing graduation or a post graduation is what he is expecting to do after completion of that graduation and post graduation. So let me tell you some of the basic things or basic requirements where these computer grads are being widely required. So these are some of the companies, VLSI companies, and say some computer companies which require these computer science graduates, but they are not getting those graduates. Even I'm talking about general. I'm not talking about biomedical engineering, but I'm talking in general that these companies are looking for computer graduates basically for programming and all, but we are not able to find those say peoples who are really reliable in working in programming and all. So these companies are available over there. You can go through Google and you can search for jobs in computers in biomedical engineering also. And the basic that I need to tell you in this presentation, because I'm really concerned about your future. So biomedical computing, BA and BS with medical preparation, how many jobs are available in there? Apply computer science principles to solve problems in medicine and healthcare, and we can have examples of areas like electronic medical records. I have my PhD on this, my doctoral research on electronic medical records, and then patient care and monitoring, medical decision support, telemedicine, medical imaging, and also having computer guided surgery. I have already told you that we can do a virtual surgery. The doctors do surgery at their workplace on a screen, whereas the robots perform the actual surgery at a distance, played at a very long distance. So these are some of the fields where computer peoples, BSc computer or BA computers peoples are required, are being required. And one more thing I would like to tell you, in India itself, we are having many more specific biomedical engineering colleges where we can go through the graduation and post graduation in engineering as well. In foreign, we are having universities of biomedical engineering. Just imagine, we are having universities of biomedical engineering because this is a widest and very wide scope where we can employ peoples, right? So universities are there, and you can do your post graduation over there in by applying for scholarship and all, and you go through that. So you'll be having a lot of job opportunities in abroad also. So these are some of the fields which I need to talk to you, and the peoples which are being appointed over there being highly paid like anything. So you just need to go through that, and the sky is the limit for those people. So this is what I was telling you for today. And then we have career opportunities in biomedical computing, so we can have the roles like this. We can be managers, project designers, researchers, programmers, system analysts, educators, physician, and whatnot. So these are some of the career opportunities where you can uplift yourself and you can make a career in your futures, right? So go through those opportunities. The first and the foremost thing is you should go through your graduations with that frame of mind and with that sincerity and honesty. Complete those things, graduation and post graduation, and the technically different things which are being required. You can take that from say any of the universities and colleges, and then you can go or you can land in a very good job prospectus, right? So these are some of the opportunities that I need to discuss with you people, because actually you are from computer science field. So this is that, and these are settings of some hospitals and healthcare system, health information technology, vendors, e-health companies, insurers, academic departments, clinical and research. There are many scopes where we can do our careers, right? So this is that. Then the conclusion lastly that the importance of DSP in biomedical engineering is quite clear now. And I guess that you have understood what is the wide field called as biomedical engineering. And without DSP, it would not be convenient for the doctors to give proper treatment to the patients also. Right now, we are talking about the computers which are expected to give medicines to patients, just looking at them or just referring to their symptoms. Results would be uncertain without DSP, so results are proper by using this. Then efficiency of medical instrumentation is enhanced by DSP, digital signal processing. The instruments, they can be calibrated by using this data. Then yeah, in this pandemic COVID-19, I guess this is it is very useful that DSP based devices for maintaining social distances are being widely used. You are remembering that robots are being used to say disinfect the hospitals and all. So these are some of the conclusions which I need to tell you. And lastly, I would like to thank the organizers for giving me this opportunity to present my work, my talk on biomedical instrumentation, biomedical engineering, and please give me a chance to place a sense of gratitude to Dr. Gulhane sir, Dr. S.P. Joshi sir. They are very, say, very near and what could I say? I very short of words to for them, and I request sorry, I thanks all of them, all the organizers to give for giving me this opportunity to talk with you. Because thank you very much. I hope you have got this topic, and if you have any questions, we can. I will try to answer those questions. Thank you very much.
Thank you, sir. Thank you very
Thank you.
much. Indeed, it was a very informative and enriching session by Dr. Nilesh Meshram, sir. Thank you, sir. The knowledge and wisdom you have imparted with us about the topic computers in biomedical engineering and its future prospects. It will help us and support us to large extent. Your talk gave us great boost to take interest in this area. Thank you very much, sir, for stimulating address.
Thank you, ma'am.
Now, I would like to Miss Reena Urkande to propose vote of thanks. Over to Miss Reena Urkande.
A very good morning to all faculty members and my dear student. Thank you, ma'am. It's my privilege to have been asked to propose a vote of thanks on this memorable webinar. I, Reena Urkande, on behalf of Prerna College of Commerce, Department of Computer Science, welcome you all. First and foremost, I thank our honorable speaker, Dr. Nilesh Meshram, head of the department Electronics in Sri Mathuradas Mohta College of Science, Nagpur, who in spite of his busy schedule has found time to grace this webinar and immensely enlighten all our students on the topic computer in biomedical engineering and its features prospect. He told us the role of the computer in medical field, maintaining the record system and basic instrumentation system, application of DPS in biomedical engineering and heart rate sensor for the Arduino plus sensor, hearing aids is an electronic sound amplifier. It was a wonderful experience listening to his on this occasion. We express our profound sense of thankfulness of his kind address. Thank you so much, sir. I would like to express our sincere thanks to our Honorable President of Prerna Seva Mandal, Professor R.C. Gulhane sir, Secretary of Prerna Seva Mandal, Dr. R.C. Gulhane sir, for their kind permission to conduct the webinar. Their able guidance has always encouraged us. I thank them for their kindness, their interest, and their continuous support. My hearty thanks to our respected Director Praveen Joshi sir, Prerna College of Commerce, for his continuous motivation, support, vision and commitment. I must mention our deep sense of appreciation to our officiating principal, Dr. Bhati Deshmukh Madam, for her continuous guidance. I thank all the head of department and the faculty for their support for this webinar. I owe special thanks to technical department who have worked hard to ensure that this webinar become a memorable success. I thanks all dear students for their overwhelming the responses and feedback. I'm sure this webinar will help them to sustain in this pandemic situation patiently and create a sense of responsibility to handle such a situation. At last, I thanks all for making this webinar a resounding success. Thank you, sir. Have a nice day.
Thank you. Thank you very much.
Thank you.